Every time you're using ChatGPT, you're using some electricity. Did you know that? By 2030, the global energy demand from data centers, so those using AI, is expected to double. They'll be using almost as much power and energy as the whole country of Japan is using today. That's a 165% increase in energy consumption compared to 2023 levels. And it's happening way faster than people realize. So let me show you and talk to you for a few minutes about what is powering your GPT prompts, and also talk to you about what it means for our energy future. So let's start with scale. Goldman Sachs forecasts the global data center electricity we use will increase by 50% by 2027, and then by 165% by 2030. So this isn't just AI and web hosting, it's the cloud services, the games, the video processing, and much more. Training large models like GPT-4 consumes over 50 gigawatt hours of electricity, about what San Francisco uses in 3 days. The training cost alone exceeds $100 million. And that's for just training it once. Retraining the model and having it learn over time, it makes it even more of a hungry energy monster. 1 billion ChatGPT queries per day for a year would consume over 109 gigawatt hours of electricity, enough to power 10,000 US homes for a year. And that's just for text. When we start adding in image and video generation, that really multiplies the energy footprint. So where will all this power come from? In the US, data centers are expected to account for nearly half of all electricity demand growth in the next decade. In Japan, they'll drive more than half. In Malaysia, up to 20%. Today, US data centers use about 3.5% of national electricity, and that's projected to rise to 8.6% by 2035. So that's more than double, and it's creating a grid bottleneck. So to support this growth, the electric grid, is going to need $720 billion of investment through 2030. But transmission lines can take 5 to 10 years to permit and build. Data center expansion is now outpacing utilities' ability to deliver power. In the last 18 months, developers have hit a wall. Utilities can't upgrade transmission capacity fast enough due to permitting delays, supply chain issues, and aging infrastructure. So let me translate that for all of us. We can build these AI data centers way faster than we could power them. And so this is creating a clean energy challenge. Globally, data centers still rely on fossil fuels for 60% of their electricity. Renewables provide 27% and nuclear 15%. So even as tech companies like Google and Meta and Microsoft pledge to have 100% renewable goals, the background behind it is a little bit more complex. 2/3 of future capacity is planned to be renewable, but we're also building new natural gas plants in the US to meet this demand. Some companies are even exploring restarting retired nuclear plants or making direct deals with utilities to secure dedicated baseload power. As most sectors decarbonize, data centers are one of the few where emissions may continue to rise. And so here's a little bit more on what that means. Data centers tend to cluster in specific regions, and that will strain the local grids. Northern Virginia, for example, already has one of the lowest grid vacancy rates in the US. Tech firms are making massive power deals, and these often have costs that flow to the residential customers like you and me. And in some cases, these deals may drive higher electricity bills for everyone else. But at the same time, there is some nuance because we are becoming more energy efficient. Faster chips, better cooling, and larger scale facilities are reducing the power per computation. And some operators are even turning their data centers into grid assets. They're adding on-site solar, batteries, and flexible loads that can help stabilize the power demands. So now I bet you're wondering, well, what's the big picture? Global electricity demand from data centers is on track to more than double in just 5 years. AI is only accelerating that trend. And while the AI boom is transforming everything from healthcare to science to our daily lives, it's also straining an electric grid that wasn't built for this kind of energy load. So the question is, can our grid keep up with AI's growth? And do we have plans to help our grid adapt? Let me know what you think in the comments below, and have a wonderful day.